Hello and welcome back to IXL Tutorials. This is Mr. Duffick, and today we are doing IXL Tutorial R4, which is all about trigonometric functions of complementary angles. Okay, so I want to explain something to you before we start this first problem so you kind of understand what's going on. So the title of this thing has to do with complementary angles. And remember, complementary angles, when it comes to geometry, are two angles that add up to 90 degrees. And it doesn't matter where they are, where the angles are within the triangle or whatever, but if two angles add up to 90, they are going to be complementary. And now I want to bring you back to this right triangle that I stole from the internet. I took a snip of it. And what we're dealing with here when we go with trig functions is we're going to have a 90-degree angle here pretty much at all times, okay, at least for these problems. Which means our two remaining angles, we'll call this angle x and angle y, have to be complementary. X plus y has to add up to 90 degrees, right? Because if all three have to add up to 180 and this one's always going to be 90, well, that means the other two have to add up to 90, right? It doesn't matter if it's 89 and 1 or 45 and 45. These two are complementary. And the IXL says this. They say that all the problems you're going to encounter have to do with complementary angles. So this is what you should imagine when we're doing these problems. We're dealing with right triangles here where we have an angle x and an angle y with that right 90-degree angle there. So with that in mind, let's look at the first problem. So it says sine of x equals 0.8. And if x and y are complementary, which they're going to be, right? X plus y is 90. Then what is cosine of y? Okay, the answer to this is very simple, and let me explain it. So remember we have SOHCAHTOA. SOHCAHTOA. Okay, meaning we have sine is going to, let's say sine of x, is going to be equal to the opposite side over the hypotenuse. And for cosine, that's going to be cosine of x is adjacent, as in the side next to that angle over the hypotenuse of that triangle. Okay, so this should be reviewed at this point. So I want you to think about this. Sine of x is going to be 0.8, meaning the opposite over the hypotenuse. So we'll go the opposite side over our hypotenuse here is going to be going to equal 0.8. So I'm going to make arbitrary letters here. We're going to say A, point B, point C. So what sine of x really is, sine of x, is going to be the opposite of where x is. So BC, we'll go BC. We don't have lengths here, so I'm just going to write the sides. The BC over the hypotenuse, which again is always, excuse me, the side that is opposite of that 90-degree angle, the slant. Hypotenuse is going to be AC. Okay? So that's sine of x. Now let's do cosine of y, because it's asking for what cosine of y is. So we'll do cosine of y. Because remember, one angle is x, one angle is y. They're going to add up to 90. So we'll go to y, and y, or cosine, is going to be adjacent over the hypotenuse. So we have our angle here, and adjacent means the angle that is next to or intersecting with this angle right here. So what side is touching this angle? Well, we have this side here and we have the hypotenuse. And the hypotenuse is always by itself. We don't touch that. So when we're talking about adjacent, we're going to be talking about this side right here. So the adjacent side to angle y is going to be BC. And then, of course, it's going to be adjacent over hypotenuse, and the hypotenuse is AC. So what you might have noticed is sine of x is BC over AC, and cosine of y is BC over AC, meaning cosine of sine of x and cosine of y are going to be equal. They're the same exact thing, right? So we go back to our question, and it says sine of x is 0.8. What is cosine of y? Well, it's the same thing as sine of x, which is 0.8. So our answer is going to be 0.8. 0.8. Okay. Now you're going to see problems like this. So I'm going to come up and I'm going to kind of start erasing this. So here we have cosecant. Okay, and remember that's correlating with sine. It's inverse sine. So it's the same thing as saying 1 over sine. That's going to be cosecant. And then instead of giving us an angle, like, or a value, just a value, 0.8 or something like that, they're giving us an angle of 90 minus x. So not just x or y or something like that. And so I want you to think about this again. So we have angle x right here. We have angle y right here. Okay. And we'll do cosecant as 1 over sine. So we'll just begin with doing sine. So sine of 90 minus x, well, what is that going to equal? Remember, x and y are complementary. X and y have to add up to 90 degrees. So we have x and y in this triangle, and we can write that out algebraically as x plus y equals 90, right? That has to be true. When you add x and y together, they have to add up to 90. Okay, so we can manipulate this equation to basically make it match our little angle value right here. So if we subtract x to the other side, cross the x out, we're left with y equals 90 minus x. Okay, so now we have our 90 minus x, 90 minus x. So writing 90 minus x is the same exact thing as writing just y. Y is going to equal 90 minus x. So sine of 90 minus x is really just saying sine of y, right? Because 90 minus x equals y. And so if we look at the other part of the problem, it gives us secant and wants us to find secant x, which is really just cosine x, right? But remember, the question is asking us for cosecant and secant. Cosecant is directly related to sine, so really it's asking for cosecant of y. And secant is directly related to cosine, so we're just going to write secant of x. That's what it's asking for. Okay. Now, remember, the sine and cosecant are inversely related. So since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. So we'll go to angle y, which is down here, and we'll do the hypotenuse over the opposite. So the hypotenuse, of course, is going to be AC over the opposite. The opposite of where y is going to be AB. Okay. Now let's do secant of x. So we'll go to x up here. And remember, cosine is adjacent over hypotenuse, so we're going to flip that over. So it's hypotenuse over adjacent. So the hypotenuse is always going to be AC for this problem. And then the adjacent of where we are here with angle x, it's not going to be the hypotenuse side, it's going to be the other side that's intersecting or touching that point, which is going to be AB. Okay? And just like last problem, surprise, surprise, AC over AB equals AC over AB. Cosecant of y is the exact same thing as secant of x. So they give us cosecant of y, right, it's 90 minus x, same thing, as negative 5 over 2, and therefore secant of x is also going to be negative 5.2. So you can see that finding the answers to these things are really easy. You know, they're generally going to be the same thing as the kind of the answer to the trig function they provided. But you got to understand how they're getting it, not just writing down the answers here. And so this is going to be the same problem where we have cosecant and we have secant. Okay, x and y are complementary, not too different. Okay, so for this problem it says find a value of x that satisfies the equation cosine of 14 equals sine of x. Okay, well, remember, if those two are going to be complementary, we go back to our triangle here, x and y have to add up to 90 degrees, right? Meaning cosine of 14 is going to be the same thing as sine of 90 minus 14, which is going to be 76. Okay, find the value of x that satisfies the equation sine of 19 is cosine of x. Again, these are going to be complementary. They're going to have to add up to 90. So 90 minus 19 is going to be 71. Okay, we have cosine of 29 equals sine x. So 90 minus 29 is going to be 61. Okay, sine of 28, so it's going to be cosine of 90 minus 28 is going to be 62. Okay, here we have cosine of 130 equals sine of x. Remember, it's whatever we need to get to 90 degrees. So how do we go from 130 to 90? That's going to be negative 40 degrees. Okay, negative 64 for cosine, what is going to be sine of x. Remember, it's whatever we need to do to get to 90 degrees. And so that's going to be 90 minus a negative 64, which is 90 plus 64, which is going to be 154. Okay, cosine of 11. So remember, we need to get to 90 degrees. So how do we get from negative 11 to 90 degrees? That's going to be 90 minus a negative 11, which is the same as 90 plus 11, which is going to be 101. Okay, so you get the idea. We're already up to 89. Let me skip to the end over here. Yeah, same deal here. How do we get from 262 to 90? Well, that's going to be a minus 172. Okay, so you get the idea. I'm going to jump to 94. So this is where I'm going to end the video. It doesn't let me go any higher than this. So stay safe, take care, study hard, and I will catch you for the next IXL tutorial video later on. Goodbye.